So hi, welcome. Somebody pointed out to me that SDOM looks like Sodom from Sodom and Gomorrah. So I realized I didn't name it, but on the bus people are having biblical thoughts, but that's okay, of course. But it's called SDOM, so not to be confused with the city from Genesis. So an SDOM approach to web audio that I'll be presenting today. So a bit about me, just to kind of contextualize where I'm coming from. So 2011 to 2017, I worked at the Earcom and Graham on various digital audio roles. I started my own company in 2017 to work on ML DSP-based audio, and we wound up exiting to a reputable group of seasoned professionals with the company. And then on the heels of that resounding success, I started a company with the same founders, backed by the same investors. So that's me. And then where I landed, so we're building a demo social rhythm game app now with my company called Joyride FM. If you're bored during the presentation, there's many ways to spend your time, but one is going to that website and playing the game. And then we've open sourced our stack on GitHub, which includes the following 4 libraries. So one's called Hyrule, functional reactive programming library, Deku, yet another web UI library a la React, Rito, a set of 3JS bindings, and what I'm going to talk about today used to be called WAGs, but now it's called Ocarina, a web audio library. For those of you that are Zelda fans, you'll realize that all the names come from that. But of course, like everybody in the room, I try to do word salad. So for Rito, I have reentrant, idempotent, temporal, oculars, and there you go. So if anybody wants to come up with a better name for these libraries, then feel free also to play at that during the presentation. So what I'd like to start with is sort of the why, what, and how of what's going on. So why? We're building social rhythm games in the browser, right? So this is kind of an example of it. So this is just the tutorial. It shows how to play. It's a phone-based game, so you're supposed to use your thumb to press and stuff. So I'll click. I was on time because I went to a conservatory, so I have that ability. So that wasn't on time, but that's fine. So social rhythm games, there's pre-recorded tracks, there's live tracks, things that come in, and it has to be at 60 FPS, which this is, and of course it's in the browser happening right there. So let's exit the tutorial. So that's what we're building. Why? We're building a social rhythm game. So this is kind of motivating the framework for it. So perhaps you and I know several of you are building games engines or building audio SDKs. So if that why sounds like your why, then hopefully this will be a kind of an interesting presentation for you. Rhythm games, what do they need? They need to be reactive. As you saw, I'm clicking on tiles all the time. They need to have a tight rendering loop, 60 frames per second. And we saw that with Wise that Philippe presented as well. Like it just has to. It can't lag, otherwise people will bounce from your game. And in this particular case, it needs dynamic signal processing chains, meaning that it's not just that we're triggering one sound here and one sound there, but we can trigger entire effects which take the whole entire audio graph, for example, into a low-pass filter if a certain event happens in the game. So instead of having this one-off logic, it kind of has to, or at least we've decided it has to have a graph-based logic. So the what? So what are we going to learn about today? So I'm building rhythm games, and I'm using an SDOM approach to web audio. SDOM is short for static DOM, in contrast to VDOM or virtual DOM. And you might have heard VDOM if you work with React or Angular. It's a technique. So my claim is that SDOM as a technique is going to allow me and perhaps allow you to realize engines that kind of run at the speed. And what I'd like to teach you today are the basics of how to implement that sort of approach and show a couple of benchmarks. And then how I'm going to do it is with PureScript Ocarina, an SDOM-inspired web audio library that myself and others wrote. So to recap, why to create reactive immersive games, what you're going to learn is the SDOM approach, and how is through PureScript Ocarina. So by the end, I hope that you'll understand what it is, what forces led to it, its major design choices, and its limitations. So I'm going to do a bit of history. And just so you'll be able to conversantly kind of understand the trade-offs and decide, is this for me or not? You'll know when to reach for these patterns. So like you're sitting there in your office, you're writing code, and like you kind of after I'm long gone and we've parted ways, like when is this little chunk of information perhaps useful for you, and when can you use it during like 15 minutes of a coding experience to maybe speed stuff up or make your app a little bit more stable. And then I hope that you'll take away a little bit of the theory behind it too, because it uses functional programming. So those are my hopes. At the end, maybe I'll ask you if I achieved those 3 things, and I hope that you answer with a resounding yes. So goal 1, what is SDOM? So before SDOM, there was VDOM, so virtual DOM, introduced by Angular and React. So what is a VDOM? In a VDOM, an app is a function from a data model to a DOM. So you have a data model that comes in, and a DOM, or a virtual representation of a DOM, comes out. And when the data model changes, we diff the new virtual DOM against the old virtual DOM, just like what Git diffs the new repo against the old repo, comes up with a patch, and then we apply the patch to the real DOM. So essentially, by diffing, we see what's changed, and we apply that as a patch. And that's ubiquitous. That exists in React. That exists in Angular. And if you use Tone.js under the hood, that's how the engine works as well. And I'll have some benchmarks with Tone. So you could say that Tone is the VDOM, but V audio so audio object model, if that exists. DOM, by the way, stands for document object model, and it's kind of what's involved in the layout of documents. So there was a seminal paper in 2018, or at least seminal for me, called "You Might Not Need the Virtual DOM," which was heresy because it was the height of that. So of course this person comes in and decides to throw out the baby with the bathwater and says, denotationally speaking, the virtual DOM is very appealing, but operationally it is a heavyweight solution for many problems. This is important. Every time, and think about games, right? They can't be heavyweight, so this interests me right away. Every time we modify our application state and return our render function, we allocate a new tree of virtual DOM components and perform a tree diff in order to discover what must change in the actual DOM. For most applications, this seems to be overkill. We can optimize the diff algorithm in various ways, but ultimately the diffing is essentially unnecessary. And this is a little bit like what Paul said yesterday, that kind of the best way to optimize something is not doing it at all. So even if you have this super optimized diffing algorithm, you still have a diffing algorithm, and it's going to take time. But in simple changes, you know precisely what needs to be updated. We simply need a way to make this obvious in the code. And that way is what he invented, SDOM. So the design principles. The nodes in a graph never change. And that's why it's called static DOM. Asterisk, except for when they do. And I'll get to when that happens. But imagine that it's static. So you create a bunch of nodes and they just live, meaning that like you have 10,000 sine wave oscillators, and that's it. You allocate them and you never take them away, and they're just there in your graph. And you have 20 gain nodes, and you just allocate it. So stuff's not coming in and out on the fly like the piece starts, and you just allocate a whole bunch of stuff. So that's the first thing. Next, nodes listen to event streams that modulate properties. So you have an event stream that's firing like a frequency event. And because it knows that the node was allocated, it doesn't need to do it if node exists, then otherwise. It doesn't need to look at a diff to know if the node was destroyed, because it's not going to be destroyed. So it's static. So you just have event streams that know that a node is going to be present and then modulate it. So that makes it fast. And because the node is static, event streams can cache a reference to the node. So that means no more calling like document get element by ID. Now, this is the DOM. So audio, we're not calling document get element by ID, but in the DOM, you can cache it once and fire and forget to the node, and you know it's always going to be there because it's never torn down, because it's static. So that's the methodology. That's the important bit to take away. Hello, SDOM. So this is SDOM code in PureScript. That's my language of choice. This is it working in my browser. I'm sure that you would have believed me that it works otherwise. But so the way that it works, it looks very much like, so if your PureScript syntax is foreign to a lot of people, and I'm sorry about that. But here, there is a static div, a static button. So this never flies in and out. There's no diffing to say, did this button disappear or did this div disappear? It's all there. It stays. And then what changes, you see that stuff's updating. And all that's updating is an event stream in this text. And this event stream grabs a reference to the text. And every time the text needs to be updated, it doesn't diff the DOM. It just hydrates its reference with the new value. So by making that architecture and that design decision, it winds up being blazingly fast. And for this little web application, its speed would not be an issue in any language. But when it scales up to something like the game that I showed you, the speed is kind of make or break for the quality. So again, that is how an SDOM app is set up. Hello, SDOM audio. So a bit the same. This is kind of an involved example, but same thing. You have a delay that has a gain. This is a fixed point operator. So in functional programming, a fixed point is a function that takes itself and returns itself. It's called a Y Combinator. So a fixed point in audio it's a loop, is a feedback loop essentially. So you could have fixed points in a graph. Kind of anything from graph theory that can be in a graph is representable in the SDOM model. And fixed points, of course, are important to have reverb. So this is SDOM. My browser. This is me modulating in real time. So I'll do it again because it might not hear. So here there's I think 20 simultaneous feedback loops that are all being rendered in real time on a canvas. And it reacts immediately to the slider, meaning the slider is changing the length of 20 delay lines simultaneously, and it's doing it with kind of no droppage and no issues in the. You hear no clicks, no bleeps, no bloops in there at all, in spite of the fact that it's an extremely dense over 100 node web audio graph, because all that's happening is that whenever I drag the slider, it is a sending event. It caches the audio nodes. It knows exactly which audio nodes it modulates, and it doesn't need to kind of look through a tree. So that speeds up stuff quite a lot. So let's do a benchmark really quick. I'm going to open and inspect it. This is in the paper as well if you're interested. Of course, benchmarks are awful because they're designed by the person that creates them to make the other guy look bad. I'm guilty of that as well. But so that being said, also benchmarks use awful sound. So like I decided to one-up them and use a really awful sound. So I'm going to turn it on. It's quite unappealing. Sounds like a fire alarm. So this is a node just being like allocated, torn down, allocated, torn down. But they're all there. It's just that they're like being used and then not used. So this is SDOM. I'll stop it. And if we look at the profiler, I'm not gonna. So I told Paul yesterday that I feel a little guilty showing a profiler in a sort of casual way and not digging a deep way. But I would just like you to look at the geometry and see that it's not that dense. Why is it not that dense? Because every time that a function is being called to turn on or off an oscillator, the call stack is really short. It's just saying call that function. As a result, this library that we're using occupies this little tiny sliver, right? It's almost none of the loop. The same thing implemented in Tone.js, and this is the code, by the way, is kind of short and sweet. I tried to make it idiomatic. I made this idiomatically Tone.js. Same example, same exact example, a little softer, but otherwise the same. Just following their documentation, like no more, no less, same as if you follow mine. We're going to profile it, and hopefully mine will be faster. Otherwise, I will be super embarrassed, but I think it will. Turn it off. And it is. So this is at 690. The other one was at 70. So it's about same number of seconds, about 10 seconds. I forget exactly what, but you can even see visually it's roughly 5x more. And the important bit is the density of the trace. So what is happening in the density of this stack trace? If you zoom in, and I talk about this in my paper, but a lot of these algorithms, for example, for each tick between, is the VDOM algorithm in Tone.js performing the diff and seeing what sign node is there and what sign node is not there. And if it's not there, I'll tear it down. So you have this VDOM approach in Tone.js that slows it down quite a lot for these types of things. Of course, even this is quite good performance, meaning that it occupied like 10% of the rendering loop, but the SDOM approach occupies 1. And when you're doing like when every millisecond, nanosecond counts, it can make or break your application. So that's that. So SDOM's advantages: build a graph declaratively, like in Fausto.jsx. It's fast thanks to upfront allocations, and each reactive component is very efficient. So when and how do I use this? You practitioners, you're not writing in PureScript. Most of you, if not all of you. So case 1 is for fixed graphs. So for example, if you have like, this is like a fixed graph, doesn't change over time, like a good time to use it. You can see that's just like an audio graph, and the nodes are not coming in and out. So another one is if there are bounded outcomes, and by that I mean that in SDOM, events don't need to inject just control values. Events can inject sub-DOMs. It's kind of like you could put an iframe in your DOM, right? And then you have a whole DOM. So the SDOM, that's how you cheat. That's how it's not static, because into the static DOM, you could inject other static DOMs. It's sort of the dynamic backdoor, just like into a web page, you can inject an iframe. So here, it's a little bit loud, but I'll turn this on, and it's injecting dynamically thousands of sub-DOMs to create a wind chime. Each chime that you hear is its own buffer. So I've already, just by doing this, allocated thousands of them. No clicks, no glitches, no bloops, no bleeps. Like now, well over 1,000 dynamic nodes. So and it works, and the code is kind of up here for how that's done. If you're interested, it's on the documentation. So if you're working with bounded outcomes, it could be a good choice as well. Its limitations is that the dynamism has a bit more difficult mental model, and it's not very JavaScripty. So what I'd like to finish with, I think I have 5 minutes left, of which some need to be for questions, is a little bit of theory, because I think the theory behind SDOM is quite beautiful. So the type, I've been talking about events, right? The DOM receives events, but like, what is an event? Like, okay, I'm going to stop throwing around that word and kind of put some meat on the bone. So the type of an event in PureScript, you see what is up there. It's a little hard to read types in TypeScript, let alone PureScript, a language that most of you haven't seen before, but I'd like to just tell the story of what it's saying. So it's saying, if you give me a function, that's the first argument to the type. So the first argument to the type is a function. The type is a function that takes a function. If you give me a function that I could call every time a value comes in, I will return something to you, effect unit. So effect is a thunk in PureScript. The outer effect you thunk to turn it on the stream, and the inner effect you thunk to turn it off. So it's like a faucet, on, off. So if you give me a callback that I can call with values, I will return you something that can turn on and turn off the callback. So types in TypeScript or in any language are like contracts, and this is the SDOM contract. So the interesting thing about this, it's also called continuation passing style, and functional reactive programming is another term for it, is that it unlocks really important patterns. So for those of you that have worked with Haskell or Scala before, you know what a functor is. And a functor, you can do something map. I think that a lot of you have used map before with arrays or map reduce. You could define a map function for event. That's the definition of it. And what that means is that you can map over an event, meaning map over every value in a stream, just like you map over an array or map over a maybe value. That's pretty cool, because that means that you can use these functional programming patterns out of the box with this model. There's a bit more theory too, but I'm running out of time. So I just want to kind of give you a glimpse of what's going on. So to summarize, SDOM is an alternative way of modeling a DOM that can be applied to audio, as you saw here, that allows you to create very fast applications in cases where speed matters. So that's me. That's what I'm up to these days. I'm building a game. I hope that those of you that if you were looking at your phone, you were playing it. If not, it's at joyride.fm, the little demo, and I'm happy to take any questions. Thank you.
Thank you very much. Do we have any questions from the audience? Yeah, I was wondering if you also apply this approach to 3JS, wrapping 3JS graphs, and how that works out.
So the PureScript Redo library that we have wraps 3JS, and we do exactly that. There's some interesting differences though. One being that 3JS is not hierarchical; it's a scene. So there's occlusion, things that cover other things. But where SDOM could be really useful is in the listeners. So for example, raycasting. SDOM speeds up raycasting radically, and raycasting is used to click the tiles. And when you have like many tiles being clicked simultaneously, it really speeds stuff up, we found.
Hi, thanks for the talk. I didn't know about that approach, so thank you for that.
Yeah.
So you mentioned, you talked a lot about the way you approach SDOM for web audio nodes, but are you also using it for the visuals of your game, like using DOM?
Yeah, so the visuals, the 3D renderings in 3JS, which I just mentioned, but also the DOM, like kind of the welcome menu and everything is running that way. So for example, in the game, there's like little messages that popped up that said like nice or bad or whatever. And those little messages are not rendered with the 3D rendering engine because it takes way too long to download the fonts. We just use a div with that. And that div responds to the same exact event that my audio responds to. So it kind of creates this nice synergy. If kind of multiple libraries buy into this model, there's a compounding effect. Yeah.
Okay, and maybe a follow-up question. So clearly you were concerned about performance when you started this project, and you knew you had to have something optimized, and you were already aware of the dangers of using virtual DOM also for audio.
Yeah.
So with those two things in mind, why did you decide to go with this route and not decide to go the way of, for example, doing just one audio worklet node with an optimized DSP running inside?
I think so. It's a really good question. For me, the act of using events, like mapping over events, like I showed at the end, you can map over it like an array. You could also compose two event streams together so that you could filter event streams. There's lots of things that you could do with an event just because of the type that it is and the type class that it implements in Haskell and in PureScript. So for me, the choice to do it was one of knowing that by creating something that obeyed these laws with the type system, it would allow me to compose things together kind of in this process of almost creative discovery, if that makes sense. Whereas I'm not saying that you can't do that with a single web audio node. You could also be creative through that. But I feel that a lot of people that are into functional programming, which I very much am, see using the type system as a kind of a way to surf creativity, and kind of it will lead you to places that you might not have thought you go. So I wanted to afford myself opportunity, and that's what happened. Like I've been able to make kind of choices that have surprised me, and inversely see people that make choices that surprise me because it adheres to that type system.
Okay, thank you.
Yeah.
Yeah, I would also be curious, how does this relate to frameworks like Svelte? So that's like a different approach again. I think it's not static, but like it keeps references to every node's and render time. So
yeah, so Svelte, there's another called SolidJS, and they occupy a similar space. So both of them have dedicated compilers, and I would say that those frameworks are industrial, meaning they're for people that like don't mess around essentially. So like you have one goal, and it's to do all the things that industrial product needs, which includes onboarding junior developers. So one really nice thing about Svelte is it looks like HTML. So you could hire somebody that just did a boot camp and came out, and they could be really productive really quick. So that's industrial, and there's many other things that are optimizing for that. It sort of, you lose a bit of the richness of the type system, but if, like, I say lose not like in a pejorative way, it's just that's the trade-off, right? I wanted to have that. My co-founders wanted to have that because we enjoy it. So I think Svelte is great in an industrial context, and any dedicated compiler is always going to be better at what it does, or almost always, than a general purpose tool. But I do think that ours is compelling enough performance to make it worth working in this general purpose language that's pure script.
Very good.
Okay.
Yep. Thanks very much.
Thank you.